你布料上面有看我这个吗？雷姐应该是这样的，哦，对，哦，我知道了。啊，哦，这里，这样子，这样子。
Virgin 96, wind 070 at 15, good for takeoff, runway 08 right today.
We're going to help create a strong community.
本次大赛将于7月29日截止报名。
大家好，我们是 MIT Chief 麻省理工学院中国创新与创业论坛。我们致力于推动中美之间高科技领域人才与技术的交流与合作，打造北美第一创新创业品牌。
第5届 Entrepreneurship 中国行将于今年夏天带领15支优秀的北美创业团队回到中国，深度接触和融入当地的创业生态系统，
绽放科技和智慧的魅力，开拓具有国际视野的中国道路。
把有趣好玩的科学课程带给更多的中国小朋友。
通过基因组学和人工智能的方法加速罕见病的诊断。
To prevent the unnecessary incubation of over 3 billion male chicks annually.
更快速以及更经济的生物分子检测技术。
普及先进医疗资源，启迪智能诊疗标准。
健康以及饮食管理的贴身 AI.
Connect elite Chinese engineers to US-based startups.
Real 3D is changing the paradigm of medical education
to dramatically extend the shelf life of perishable food,
helping individuals and professionals get fit while avoiding injury and pain.
让易燃烧变成可能，低成本防癌疫苗。
MIT Chip 中国行将在未来继续与各地创业生态系统建立长期信任合作关系，鼓励更多前沿项目了解中国市场。
科技的浪潮滚滚向前，你不在潮间，就在海底。而我们为您带来的是这个世界上最绚丽的浪花，
用科技改变世界，让未来现在就来。
2017中国行
，2017中国行，2017中国行
，2017中国行。
Hello everyone, we are MIT Chief. Founded in 2011, we are committed to promoting the intellectual exchanges and collaborations between US and China in innovation and entrepreneurship.
The idea behind Co-Founders Journey is really to take MIT student entrepreneurs to take a deep dive into the innovation ecosystem in China's Pearl River Delta area.
And we want to create a precision medication dispenser that fits on all types of bottles
and goes with every type of liquid medication.
Our group developed a music therapy kit for tinnitus patients called Noise. Noise contains a bump connection headphone and an app to control it.
Using AI and blockchain technology, we crowdsourcing genetic knowledge across millions of people.
And we have better and on-demand drone delivery service for all your pharmacy needs.
The Copo Can is our solution for low-cost, culturally appropriate water purification.
We came up with Coffee Cookie, a rechargeable portable device that keeps your coffee at the perfect temperature.
Coffee is a suite of smartphone devices that can be used for rapid, low-cost, accurate testing of food and beverage products.
Their products will leverage the advanced manufacturing resources in China and be accelerated by MIT Chief co-founder's journey.
For the 10 days journey, we will spend the first 2 days in Hong Kong and the rest in Shenzhen. The program events include a one-day conference, the workshop with local hardware hackers, and most importantly, the advanced manufacturing facility tour.
Virgin 96, wind 070 at 15, good for takeoff, runway 08 right, good night.
We're going to help create a strong community.
本次大赛将于7月29日截止报名。
大家好，我们是 MIT Chief 麻省理工学院中国创新与创业论坛。我们致力于推动中美之间高科技领域人才与技术的交流与合作，打造北美第一创新创业品牌。
第5届 Entrepreneurship 中国行将于今年夏天带领15支优秀的北美创业团队回到中国，深度接触和融入当地的创业生态系统，
绽放科技和智慧的魅力，开拓具有国际视野的中国道路。
把有趣好玩的科学课程带给更多的中国小朋友。
通过基因组学和人工智能的方法，加速罕见病的诊断。
To prevent the unnecessary incubation of over 3 billion male chicks annually.
更快速以及更经济的生物分子检测技术。
普及先进医疗资源，启迪智能诊疗标准。
健康以及饮食管理的贴身 AI.
Connect elite Chinese engineers, the US-based startups.
Rail 3D is changing the paradigm of medical education
to dramatically extend the shelf life of perishable food,
helping individuals and professionals get fit while avoiding injury and pain.
让易燃烧变成可能，低成本方案疫苗。
MIT Chief 中国行将在未来继续与各地创业生态系统建立长期信任合作关系，鼓励更多前沿项目了解中国市场。
科技的浪潮滚滚向前，你不在潮间就在海底。而我们为您带来的是这个世界上最绚丽的浪花。
用科技改变世界，让未来现在就来。
2017中国行。
2017中国行。2017中国行。
2017中国行。 we are MIT Chief. Founded in 2011, we are committed to promoting the intellectual exchanges and collaborations between US and China in innovation and entrepreneurship.
The idea behind Co-Founders Journey is really to take MIT student entrepreneurs to take a deep dive into the innovation ecosystem in China's Pearl River Delta area.
And we want to create a precision medication dispenser that fits on all types of bottles and goes with every type of liquid medication.
Our group developed a music therapy kit for tinnitus patients called Noise. Noise contains a bump connection headphone and an app to control it.
Using AI and blockchain technology, we crowdsourcing genetic knowledge across millions of people.
And we have better and on-demand drug delivery service for all your pharmacy needs.
The Copo Can is our solution for low-cost, culturally appropriate water purification.
We came up with Coffee Cookie, a rechargeable portable device that keeps your coffee at the perfect temperature.
Coffee is a suite of smartphone devices that can be used for rapid, low-cost, accurate testing of food and beverage products.
Their products will leverage the advanced manufacturing resources in China and be accelerated by MIT Chief Co-Founders Journey.
For the 10 days journey, we will spend the first 2 days in Hong Kong and the rest in Shenzhen. The program events include a one-day conference, the workshop with local hardware hackers, and most importantly, the advanced manufacturing facility tour.
Surgeon 96, wind 070 at 15, good for takeoff, runway 08 right, good night.
MIT Chief.
We're going to help create a strong community.
本次大赛将于7月29日截止报名。
大家好，我们是 MIT Chief 麻省理工学院中国创新与创业论坛。我们致力于推动中美之间高科技领域人才与技术的交流与合作，打造北美第一创新创业品牌。
第5届 Entrepreneurship 中国行将于今年夏天带领15支优秀的北美创业团队回到中国，深度接触和融入当地的创业生态系统，
绽放科技和智慧的魅力，开拓具有国际视野的中国道路。
把有趣好玩的科学课程带给更多的中国小朋友。
通过基因组学和人工智能的方法，加速罕见病的诊断。
To prevent the unnecessary incubation of over 3 billion male chicks annually.
更快速以及更经济的生物分子检测技术。
普及先进医疗资源，启迪智能诊疗标准。
健康以及饮食管理的贴身 AI.
Connect elite Chinese engineers to US-based startups.
Rio 3D is changing the paradigm of medical education
to dramatically extend the shelf life of perishable food,
helping individuals and professionals get fit while avoiding injury and pain.
让易燃烧变成可能，低成本防癌疫苗。
MIT Chip 中国行将在未来继续与各地创业生态系统建立长期信任合作关系，鼓励更多前沿项目了解中国市场。
科技的浪潮滚滚向前，你不在潮间就在海底。而我们为您带来的是这个世界上最绚丽的浪花，
用科技改变世界，让未来现在就来。
2017中国行。
2017中国行，2017中国行
，2017中国行。
Hello everyone, we are MIT Chief. Founded in 2011, we are committed to promoting the intellectual exchanges and collaborations between US and China in innovation and entrepreneurship.
The idea behind Co-Founders Journey is really to take MIT student entrepreneurs to take a deep dive into the innovation ecosystem in China's Pearl River Delta area.
We want to create a precision medication dispenser that fits on all types of bottles and goes with every type of liquid medication.
Our group developed a music therapy kit for tinnitus patients called Noise. Noise contains a bunker.
And we have better and on-demand drug delivery service for all your pharmacy needs.
The Copo
Morning, everyone. Still waking up? My name is Da Jiangsuo. I'm a co-president of MIT Chief. I'm also a PhD student in mechanical engineering at MIT. So on behalf of myself, Ming He, and all the members of our executive board, I would like to thank you. Thank you very much for coming here, for joining us in this exciting event. I know a lot of you guys travel a long distance. Some of you guys might still in jet lag. So hopefully what I'm talking, so I'm gonna talk about something about MIT Chief, hopefully can wake you up. So first of all, who we are. So MIT Chief, known as MIT China Innovation and Entrepreneurship Forum. So we founded in 2011, and our mission is to connecting MIT and US-based startup with Chinese investors, market, customer. So basically, not only that, we also aims to promote the intellectual exchange, so basically what we're doing is to help and serve student entrepreneurs and startup teams. So this is So this is a brief history of MIT Chief. So we founded in 2011 with the support of our advisory, including Professor Gang Chen. And at that time, we started out with business plan context and annual conference, which is something you guys will experience during the next 2 days. And in 2013, we started our China trip. In the following year, we actually bring, so due to our China trip event, we help those startup teams join our China trip to get 2 successful funding from the government and also 2 funding from the angel investment with a total amount of more than $1 million, more than 1 million RMB. And we, in 2015, we have 2 startup teams selected by Y incubators, and 5 startup teams from Mass Challenge. You guys might know that. Join us for the trip. And I know you guys love numbers, so I'm going to give you some statistics. So far, we have 1,000 startup teams join our events. And among those startup teams, the total amount of money raised are more than 1 billion. So this is what we're doing for 2017. So basically what we're doing is we're trying to build a strong community to help, as I said, student entrepreneurs and early stage startup teams. You can see we have our trademark programs, which I just mentioned to you, including business plan competition, China trip, and an annual conference. We also, it's worth mentioning, in this year, we'll also start a brand new program called Co-Founders Journey. So the idea is to connecting MIT startup with the need of prototype building and building their initial MAP with the resources in China's Pearl River Delta area. So this is a summary of our 3 trademark programs, including China Trip. This year we have 15 startup teams in healthcare, IoT, fintech, retail, and education. And we travel to different cities, not only big cities like Beijing, Shanghai, but also a city, Guiyang, which is in the southwest of China. And we actually established an official partnership with Zhongguancun Group and also the Guiyang government. And for the context, which is something you guys will see this afternoon, we got more than 200 business plans. And we screened down to 60 with the help of our judges. And eventually 8 teams went through the finale, and you guys will see that in this afternoon. And also we have a lot of community events, including seminar, attracting more than 400 people at a meetup. So the idea is really, as I said, to help student entrepreneurs. So this is a new program we just started this year. The idea is that because a lot of our members are from MITs, and during interaction with student entrepreneurs in engineering department, like a mechanical engineering meeting lab, ECS, we found actually a lot of those student entrepreneurs, they have ideas, they have technologies, but one problem they have is to establish the partnership with those hardware suppliers and hardware incubators in Shenzhen, where they have a lot of resources to advanced manufacturing facilities. So we started this program, and we tracked actually 80 teams from different MIT engineering departments, and we actually bring 8 teams travel back to Hong Kong and Shenzhen. I would say it was a huge success. So far, 2 teams established partnership with this, hardware suppliers in Shenzhen, and also 1 team who's working on this consumer-based product actually got a seed fund. So let me share you like my idea of the future. So we talk about past, and we talk about what we're doing right now, And so what's the future? The answer is I don't know, but I can tell you, the thing I can tell you is we'll keep an eye on the technology advancement either in MIT and other research institute and in the US, including artificial intelligence, life science, biotechnology, sustainability, smart city, IoT for sure, and robotics. And the goal is to not only because we started as a China-oriented like a forum, but right now we are sort of expanding, trying to build up more partnership with local partners, including like those local VCs. We actually, one thing was mentioned is that we actually have an initial agreement with MIT's China Future City Lab, and we agreed to hold joint events next year during our China trip. So this is all for my welcome. And again, thank you for coming and enjoy the events with us. Thanks.
Good morning, everyone. My name is Ling Yan, President of Innovation Ideas Institute. Thanks for MIT for inviting me today to spend this beautiful weekend with you. I think this is a feast of ideas, insights, technology, innovation between US and China. And as you all know, it is the 7th year of MIT Chief annual event. I'm always amazed by how vibrant the MIT Chief Society is and how creative they can run these events and how innovative, how high they can achieve year by year by running out these forum between US and China. For some of us have warmed up by running some sessions last night, but for many of you who may just came over this morning, and I'm sure in today and tomorrow you're going to hear a lot of innovative ideas and technology trends from one of the most prominent leaders in business, technology, and academic field. So our first keynote speaker today, I'm going to introduce you one of the highest respected Chinese professor at MIT, as well as in the US academic world. He is leader in power engineering. He's also now the head of Department of Mechanical Engineering at MIT. Probably all of you might already guess who he is. I personally know Professor Chen Gang quite a few years ago, and I always admire him, how diligent he has been conducting his academic research and how he cares about his students and how he cares about MIT Chief. So he's a very strong supporter of MIT Chief. So without further ado, let's welcome Professor Chen Gang to deliver his keynote speech to us for today.
Good morning, and thank you, Yang. And I would like to thank Chief for the kind invitation. At the MIT, what I learned as a faculty member, and particularly now as a department head, is if you want to do something well, you ask our students to do it. And this is a really, Chief is a great example where, say, our student our students bring it from the concept. I have to say, in this case, not only they did well, the student really had that vision. Right? And 2001, when this was started, I think China's VC community, I would say, at least from my own perspective, is not as active as those days, right? So our students really have that vision to start this and see the bridging opportunity through this organization to really bridge the friendship and the business innovation between US and particularly between MIT to China. And this is a great, I'm lucky to have the opportunity to always work with the chief organization. And in fact, when I say work, I mostly did a few lip surveys and open my stomach and have dinners. But it's a really great opportunity to say this. And so I thought about so every time, of course, the beauty of this is our students move on and they become leaders, they start companies, and professors stay here. And I got a set of slides, so if you have been here a few years, you'll keep listening from me. But we always have newcomers, so I would like to really welcome people from outside MIT and to come to this event, and I hope you're enjoying this event. It's a lot of exciting research, and okay. I thought I've been using this. This is the Apple's problem.
Yeah, the drivers. Yeah, I think that works.
Yeah, there it is. Okay, so just transfer everything over. This is yours.
Just click escape. Okay, so I want to share with you my perspective. Now become almost my standard slides, but of course depends. Sometimes I give a 3-hour talk, and sometimes I give a 3-minute talk. So I this is for people from outside MIT, and as well as for a lot of students, because you don't see this summary often. And this is my one-slide summary of MIT. And sorry if you don't read Chinese, but hopefully you're gradually starting learning more Chinese. So we have, we're small campus-wise, 0.67 square kilometer. We have 1,000 faculty members. We have 4,500 undergrad students, 6,500 graduate students. But among these faculty members, you can see we have academy members from National Academy of Engineering, 66, 79 National Academy of Science. And even though MIT doesn't have a medical school, hospital, but we have 81 members of National Academy of Medicine. And this is a truly interdisciplinary research environment. And since I think among all the Nobel Prize winners, at least 75 associated. I say at least because every year is changing. This is a few-year number, and currently we have 10 faculty members, Nobel Prize winners on campus, right? And of course, those numbers say the basic science. None of this related because people are elected, given the award because of their basic discovery and basic science. But MIT, we're proud of the societal impact. And of course, surrounding Boston is this Route 128. And this is where a lot of high-tech companies are located. And of course, people are familiar with Silicon Valley on the West Coast. When you think about East Coast, you remember Route 128. And this is because I would say a lot of university here, but especially because of the existence of MIT. And we have another university just in the same town, but they don't create technology. Okay. Yeah, I'm sorry to say that. And the MIT, our alum now really started and still active, over 30 companies, and these companies generate $2 trillion annually. And if you use this as a country, the revenue, it ranks number 10 in the world. So the societal impact is huge. And of course, this is because we really got the great students and great faculty have that environment. And I want to say that this environment, particularly relative to the entrepreneurship, MIT campus has tremendous resource, right? We encourage our students hand in hand, and among all the different resources, of course, the Chief, you said, and 100K competition, and MIT Venture Mentoring Service. This is a lot of students go to seek help when they start a company, and Dash Funder Center is is a safe funding for faculty and student teams to take their technology into market in 1 or 2 years. And recently, MIT launched Engine program. It's our own venture capital, right? So it's independent of MIT campus, but it's the venture capital MIT raised and targeting investing in core technology MIT students and faculty created. And then we have the sandbox. This is through donation and any students. Right? If you have an idea, you want to try it out, it's not much money, few thousand to $10,000. If we have students here, MIT student, take that opportunity. You ask, you pretty much get it. Right? So write a proposal, you get the money and try out your idea. And failure is accepted. We expect a lot of failures. Right, and so this is really that kind of environment that created all this, say, big societal impact. And as say, really, this is for investor. This is actually quite say, amazing curve here. Those are the two curves, and those curves show the survival rate of startups, right, and small companies. This is the whole entire U.S. And if you look at it, this is 100%, 75%, 50%, 25%. After 15 years, the small companies' survival rate isolation is 25%. Well, say MIT startups is about 50%, right? So that's just the this is say if you investor, you got say twice. If I just say twice higher possibility of return, right? And I, as a department head, I have the privilege of really knowing my faculty. I don't actually have all the exact number of students, but I can say that over last 10 years, our faculty started about 50 companies, right? And at MIT, say we have this environment. The faculty and students are encouraged to take their technology to market, and faculty is you can start a company, you can start several companies as long as you limit your time involvement to 1 day a week, right? And as a department head, my other job is actually policing it. And we have all faculty file a form, and we police it so that we don't abuse students. So students cannot work in the company when they are doing PhD or graduate study with the faculty member. And that way we can protect students. But of course, our students graduate and they start company, they join the company, and the faculty student teams are very often. And so this is there are a lot of examples. I'm not going to dive into details. And I want to give you a few examples of the technology coming from my department and coming from my own research. And so mechanical engineering department is a very diverse department. And most people think of mechanical engineering, they think of design manufacturing. Yes, we do have design manufacturing, but we also have this broad range of, say, area of research. And we have 70 faculty members. I also say, as a department head, I'm very proud that students flock to us. So we have 17% of MIT undergraduate majors. Because the first year, students don't declare major. 3-year students, the total undergraduate students, about 3,300, and then we have 580 of them. And so we have design manufacturing, we have mechanics, we have control instrumentation, robotics, we have energy, we have biomedical, and we have ocean, we have micro nano engineer. So a lot of students, Chinese students are here, and I'm just amazed. I say you should be really proud you get here, because every time when I say the application from the department, many different departments in China, say mechanical engineering, we got over 10 different departments of students in typical Chinese university, and it's just very competitive. And so we're very proud. What makes it possible is our student. But say our faculty, I can just pick up these two examples, and Yanni Yanas really, he discovered the artificial skin. So invented artificial skin. And this is when burned patient suffering burning, right? The skin regrows is actually using his invention, and this invention is really saving lives and restore people's, say, the burned patient skin. You can see the impact on people's life. So he was inducted to National Inventor Hall of Fame, and he was inducted to U.S. National Academy of Engineering in the last 2 years. And Professor Alex Sachs, he was an inventor of 3D printing. And in fact, when you say the 3D printing, think about the Alex Sachs, that was his name, right? He created the name, coined the name of 3D printing, and he told me the story is his father was in the printing business. And so in the late 80s, when he coined the name, and people were just laughing at him. And but now this is say we all know the say it's the name that stick. And in fact, this was his original patent, right? And that's in 89. And out of this patent, several companies were founded out of this one invention. This was the first 3D printer. You go to MIT Museum, it's not in the museum, it's the other side of the museum. But this original 3D printer was under display there. And I don't know, say, okay. So this is, of course, we have other faculty members doing 3D printing. Alex Sachs also started other companies, and the most recent very hot company is called Desktop Metal, right? If you investors, you probably heard about it. I think the last round there is a lot of money. And this is another example. This is a young faculty member, Amos Winter. Really, his goal is developing technology to help people in underdeveloped region, in developing region. And in most of the time, when we try to transfer a cell phone to poor region, you dump up the function and say make it simpler, and try to say, okay, sell the cheaper, right? But his philosophy is really move the whole curve, have the same no cost, reduce the cost, but say keep the performance, right? And in fact, if you think about the mechanical engineering professor write article in Harvard Business Review and receive their best article paper, McKinsey Award, for his article, you can see the impact that he has. And to give two examples, this is a wheelchair, and of course, many people have seen this wheelchair, say human-powered, and we push the wheels, right? And if you think about push the wheel, your torque is constant. So you can't change the speed, right? So of course you can use your more force, but say whether he has their two simple levers, but that way you can, it's just like you're shifting your gears, right? By grabbing different place. And this was sold in India. And now he's also selling this in US, and because we say the market in US is you make this affordable so you can put it in the back of your trunk. And this is 80% faster and 60% or 70% more efficient. And that was actually during his PhD. He said that he came up with this idea when he visited Africa, and he was doing a different PhD thesis. And now he's supported by, say, a lot of India through Mr. Tata Foundation, say, donation to MIT. And this is another example. He actually has now 4 technology being developed and deployed. And this is the prosthesis. Prosthesis, of course, in US is selling for a few $1,000s a piece, right? His goal is trying to make it less than $100, and still have good performance, right? And this is his lab, second generation. I think now he's in his third generation. And you can see even in the second generation, the prosthesis leg here, the walking is already very similar to a normal walking condition there, right? And so those are the kind of technology he went to India, look at the drinking water and found there a lot of salt, and people get stones and developed that technology. Now is being deployed in Gaza. And he also went to India, look at the agriculture, drip irrigation, and that they developed new technology that's now being deployed in Morocco. So you can see really the technology our faculty and students develop are changing, impacting people. And I can tell you that this year, very proudly, among the Forbes 30 under 30, we have 3 of our graduate students received this year's Forbes 30 under 30 in the energy area and in the also manufacturing area. And this is Alex Slocum showing President Obama that he can build taller wind turbines. And you can see what's the benefit of taller wind turbines, because the taller the wind turbine is, the stronger the wind, and the same place to generate more power. And he said that he can build 100 meters taller, so you can get 10 times more power, right? And this is a startup company that's been funded by U.S. Department of Energy. And this is Professor Ian Hunter, and he's really a serial entrepreneur. A lot of, I won't tell you how many startups he has, but you can see, this is his spectrometer, and this is his mass spectrometer, right? This is visible and the infrared spectrometer, and the other is mass spectrometer. And then we all know how big those are, right? None of you use that spectrometer in the lab. It takes a whole table. And now he's making this into credit card size, so you can think about the food inspection, all the different applications, right? And he was telling me that a few weeks ago, because it's in the news, I can share, and he was doing this needleless injection, and the company was in a deal with over $100 million deal with some company. I didn't read all the news very carefully. And this is another really spectacular example. The coating inside the bottle, and more of the story. We have this faculty, Kripa Varanasi, and he was recruited from GE, and he does gas turbine coatings. And he said, joked that his wife said, "Oh, your research is not useful." So he was stimulated and put this coating inside the ketchup bottle, and you can see the impact of this. He put this on YouTube, and he said there are so many hits in months, so he got 2,000 companies contacting him, right? And this invention was applied to many different places. In fact, anything you can see, this is probably peanut butter, mustard, right? Anything in the kitchen, we throw out the 10 to 15% of the food because we can't put it out. Environmental impact, and in addition to waste, right? And this is we all have the experience of squeezing out the last speed of toothpaste, right? This is toothpaste. Of course, you don't put it in the clear box, but this is a toothpaste. And this is a pen. And even beer, you can do it so that it doesn't overflow. He said people don't like that one because it doesn't have that feeling. But anyway, you can see those kind of invention. One idea is say the impact they can have. And this year, 2 of his students was when they Forbes 30 under 30 because they invented technology to recapture the water from a power plant. Power plant, the cooling of power plant consume about 50% of U.S. fresh water, right? And if you can capture that, it's a big impact. And this is their manufacturing technology. It's just a spray on. You can see, very simple, right? And done. So let's see this one. A very interesting CNN video. Let me see whether I can make this. Doesn't have sound.
Oh my God! Our long national nightmare is over. Mechanical engineering students at MIT have come up with a super slippery coating that makes anything from ketchup to mayonnaise practically leap out of a bottle coated with the stuff. They call it Liquid Glide. Even Tony Soprano would be beholden to these students. Look how annoyed Tony gets at the dreaded ketchup clog.
And if Carlos starts talking homicide.
Liquid Glide, let it slide. No more banging with shoes or mallets or sucking up ketchup. For traditional bottles, Liquid Glide could mean their last gasp. GMO CNN, New York.
Of course, this kind of news we have. I can make my whole presentation based on news stories. So you can, and see robotics, right? Underwater robotics, the land robotics, and this is a famous MIT cheetah, where this is from Sanbei Kim's lab, and the difference of his robotics from Boston Dynamics is he built his own motor, electrical motor driven, and really biomimetic. And on the right-hand side is say underwater robotics, where we know that the bluefin that was used to search for Malaysian airline, right? That was a startup from our department. And so you can see a lot of examples, driverless car, and this is John Leonard. He's now leading Toyota, a big part of Toyota, $1 billion investment in say driverless car. And a few weeks ago, I'm gonna say you'll hear from Carl Ignima. Carl Ignima was say research scientist in our department, and his company say was recently acquired for $400 million. Right, so I still have to meet him and ask him to write me a check, and that's of course say that's part of my job as a department head, right? And this is a Professor Ji-Hwan Kim, and a really master inventor I recruited from IBM. And what he's doing is he's growing single layer, monolayer graphene, and then he can grow other semiconductors on top of this single crystal and then paired off a reuse substrate. So he's basically using a monolayer of graphene replacing all expensive substrates like silicon carbide, gallium nitride, gallium arsenide, and I say, oh, you got the platform technology, and you should join us, right? And this is a Professor Xianhou Zhao, and what he's holding is 90% of water, is hydrogel. And this hydrogel, when you say, you can say it's a stronger, very strong, in fact, stronger than human cartilage. And this one can have medical technology. And I recruited him from Duke, and the first thing he did here is went to hospital, put this into ultrasound detector. Okay, so I think my time is going up. So let me just mention quickly my own research. I still trying to do more research, but it's difficult. But one area that we're doing is really semiconductor power generation material. And there we have the experience of really taking the from the material and looking into the whole production chain and trying to commercialize that. And I can tell you more if you're interested offline. And now we're looking to commercialize a few technology. This is a plastic technology, how we can really take plastic into, normally it doesn't conduct heat, but we can make it as a good heat conductor as good as metal. And we are now also looking to the green level storage, because that's a biggest challenge for the future renewable energy. And in fact, even now we have technology, the economic analysis that we can make the economic with based on the current, say, electric grid price. And finally, this is again technology we're looking to commercialize. And for me, actually, the case, a lot of your students are very interested in entrepreneurship. I'm looking for really great teams to take the technology to market. Okay, this is the one that we can do. Basically under one sun, right? We boil water using gas, but I can say I can boil water under one sun. I can make say steam over 100 degrees under normal sun solar condition. And we're looking to desalination, water treatment. And in fact, in this domain, I have a student took a license some technology before and started a very successful company. And this is now they are treating water, oil, say from oil field, a very successful company. I think, my time is up, and I just thought I want to use those examples. I think the MIT is a really great place, and this is my sending pitch to my donors and friends. We really have the best students and faculty and the environment to create the impact to the society. Thank you.
Thank you so much for Professor Chen Gang helping us understand how powerful and how impactful MIT innovation has been making to our world. And I think MIT Chief has a very important gift for you for taking the time on the weekend to contribute your ideas. Thank you.
Thank you.
All right, here next come our first panel discussion. Of course, it is artificial intelligence. AI is the buzzword for today. Hands-on robotics, driverless cars. You can hear this anywhere, every time. And I recently actually have been personally arming myself with AI, in my life as well. I started to use my virtual assistant, helping my scheduling meetings. And right now, my cell phone messages are all, I input all my text messages through voice recognition. I recently also installed my smart home devices so that if I get home, then all my lights can get on automatically. And but where are the real opportunities in AI? Because some say that artificial intelligence is the future electricity, but others warn that human beings are inviting enemies to themselves someday. So today, our panel will help you understand what AI is, what the opportunities are, what the challenges are. So let's welcome our moderator, Will Knight. He is the senior editor for AI for MIT Tech Review. And let's welcome him to invite his panel discussion. Thank you.
Thank you. Hello. Thank you so much. It is wonderful to be here. I have. This is the third time I've been to this conference, and I have to congratulate you on putting on such an amazing event. It's incredibly professional, and always very fun. And so I've been writing about artificial intelligence for quite a long time now, almost 10 years. And when I first started writing about it, it was not particularly cool. It certainly wasn't considered the new electricity then. And it's amazing to see how interesting and how popular it is and how much of an impact it's actually having on the world. And the speakers we have for you are three people who are doing very interesting and important, distinct work in that area, making that happen. And I'm hoping we can have a really great discussion about this and also tie this back to the question of artificial intelligence in China. I recently published an article about AI in China because the growth of the technology there has been nothing short of a phenomenon, and it's going to make a huge difference to the course of the technology and to the course of China's future and the world, I think. So I'm hoping we can get into that a little bit. But let me introduce our speakers for you. First of all, we have Lisa Amini. She is the director of IBM Research Cambridge and the acting director of the MIT IBM Watson AI Lab. Her interests include natural language processing, machine translation, information extraction, and knowledge representation. And she was the first woman to lead one of IBM's global labs. Next, we have Wei-Ying Ma, who is the vice president of Toutiao AI Lab. I'm sure many of you know this, but I'm just going to say it anyway. Toutiao is a phenomenon in China, delivering personalized news to around 120 million people. And the company is worth approximately 11 billion, I think, so it's a unicorn more than 10 times over. And our third speaker is David Sontag, who is an assistant professor of electrical engineering and computer science at MIT, and he's doing very cutting-edge machine learning and AI research and applying that to healthcare. So I'm going to ask everybody just to give a very, very brief overview of their work and explain what AI means to them before we have the discussion. Lisa has some slides, but we're going to keep this pretty informal, so everybody else is just going to come up and give a brief overview. But please, first of all, welcome Lisa. Thank you.
Okay. Thanks, Will. Welcome, everyone. This is a very exciting... Oh, you want me to... Okay, great, thanks. So this is a very exciting time for me personally, and I think for our profession, really. I mean, what's happening in AI is fantastic. The recent... what I wanted to do is to... there we go. Okay. So what I wanted to do is to introduce you a little bit. If you haven't heard, how many of you actually have heard about the new MIT IBM Watson AI Lab? Okay, great. So this was unprecedented for several reasons. It's not just because of the amount of money. Obviously, it is a large amount of money. But what's really unprecedented about it is it's about advancing fundamental AI research. So being able to adapt the algorithms and find new algorithms to take on new tasks, new types of data and solutions, reasoning, and so on. So push the frontier of AI to transform industries with those new AI algorithms. We're focusing on healthcare and life sciences and security because we see those as critically important and truthfully ripe for disruption, right? So with AI. We're even going in some cases for the systems and rethinking, for example, what can quantum computing give to AI and what can AI give back to quantum computing. So really a lab that's focused on AI. It's only a couple of blocks down, so we're at 75 Binney. We're right here in the community, and this was important for us. So you might be asking yourself, why, right? Why would IBM do this? Why now? What's the reason? Well, the truth is that we are seeing that AI is basically transforming all of the industries as we know them. Essentially, healthcare is being transformed, the legal industry is being transformed, how we distribute goods, how we retail goods, everything right now is being transformed. That's important, but what we also realize is that we've seen with deep learning problems that we had been working on, we in the computer science community had been working on for 50, 60 years. We're suddenly making breakthroughs in those that we couldn't do before. So suddenly being able to recognize speech at error rates that are equivalent and in some cases better than what humans can do. Being able to recognize objects and images, in some cases better than what humans are able to do. These were barriers that we just could not break through for many, many, many years, right? So it's exciting in that right, but the other problem is that there are still a lot of challenges, right? So this is an example that some of you may be aware of. So what we're showing is basically, training on images of animals, being able to recognize images or animals within those images at surprising accuracy. So hundreds of different species we're able to do accurately, and yet add a little bit of noise to the image, and then suddenly it's not recognizable to the machines anymore. So this is something that's important, right? We have to think about how do we build systems that are robust, which is not what we have today. We have systems that are able to do very well, breaking barriers, but at relatively narrow tasks. We also have to be able to protect these systems, right? So the other problem is this image is basically showing what probing of an AI system, understanding the confidence that you're getting back, can allow another system to essentially steal the model from that target system. So we need to build AI systems that are safe as well. The last thing is that these systems, because they are kind of narrowly trained and in some cases maybe brittle, they may be breakable. So humans, in this case, were able to go out and retrain this bot such that it was saying things that were inappropriate. So we need to build systems that are robust to those types of attacks as well. So what are some of the areas that are important that we're working on, right? So one of the first areas is that humans can basically learn without a lot of labeled data. We don't need hundreds of thousands or millions or tens of thousands of images of a cat or a dog in order to know that this new thing is a cat or a dog. We don't need that. So how are we doing that? We're working on unsupervised techniques. We're working on techniques that we can take data that we do know is reliable, use that to try to provide distant supervision for our algorithms. We're basically trying to take training in one domain and then apply it to different domains. So we have many techniques that we're going after this problem, but this is a very important problem for us. We need to be able to learn more like humans. Humans can continuously adapt over their lives. AI systems really can't do that today. Essentially, you train these models, you deploy them, you may be able to adapt somewhat over time, but you're not going to be able to, the systems today don't realize, they don't introspect, they don't say, oh, I'm missing this piece of knowledge. They don't go out looking for that knowledge and then try to pull it in and represent it in a way that they can then leverage. And we need machines that can do that. We also need machines that can reason. The fact of the matter is that where we've had these great breakthroughs, they're really at the perception level of humans. So we can classify, we can predict, we can recognize patterns, but the systems today don't do that well at some of the more complex reasoning tasks, navigation, planning, and so on. So we need systems to take on those higher order reasoning tasks. And then finally, we need machines that will be able to interact with the human and kind of explain their decisions to the humans. Why is this so important? Well, if you are a doctor and you need to take an answer from a machine, you need to make sure that this is the right answer. You need to probe the machine and make sure that you're satisfied with the answer. So we need machines that can do that in a natural way, and they can't do that today. So I just wanted to try to kind of like lay out what we're doing in the lab, some of what we think are the important problems in AI, and that's all I had. Thanks.
Have a seat there. Why don't I invite David and Wei Ying up to the stage as well? We can start the discussion.
Just use this mic.
Oh, this one? Okay. Yeah, come up, guys. That's great, thank you. These guys need the mics. So David, why don't you just give us a quick overview of what you're up to in your lab and what your kind of vision is for your research?
Sure.
That'd be great.
So thanks first to the organizers for having me here. I'm very excited to be here in front of you. So I recently arrived here at MIT only about half a year ago. And I run a research lab that's joint between the Computer Science and Artificial Intelligence Laboratory here in this building, the Institute for Medical Engineering and Science, which is the one place in MIT that brings together everything healthcare related, and the EECS department. So broadly speaking, my research is looking at how can we build machine learning and artificial intelligence algorithms that are able to learn from very little labeled data, something that Lisa mentioned is very important, that can understand notions of causality, and which are able to reason about the world. And these three problems have been motivated by work that my lab has been doing over the last 7 years in healthcare. Now, AI in healthcare is actually a very old subject, something that has been studied for well over 40 years. But the time is different today. And it's not just different for the reasons that Lisa mentioned in terms of latest advances in deep learning, but it's also different because of data. So here in the United States, if we go back only 9 years, a very small fraction of hospitals had electronic health records. Today, that number is something like close to 90% of hospitals have electronic health records. Now, what that means is we have data that we can both use to learn about what's happened to patients in the past, but we also have the ability to take algorithms and implement them so that we can take the data that's available in real time and act upon it. But it's not just about having data available that is opening the door to making advances in healthcare. What we're seeing in the news today, places, people like Will, when he writes about advances in machine learning in healthcare, they're pretty boring advances.
I'll try and do better. Yeah.
They're advances that are kind of doing the obvious. They're taking settings where you have a lot of labeled data, if you know what you're looking for, and you just apply the tool out of your toolbox to try to predict that thing. And they're often the reasons why we have that large amount of labeled data is because humans already know how to solve those tasks pretty well. Mm-hmm. But unfortunately, if we really want to have this vision of transforming healthcare, and my vision, to be clear, is actually to create something called an artificial intelligent health agent, which coordinates healthcare for people, and I can talk more about that later. We need to go well beyond the settings where we have labeled data, and we need to be able to reason about patients. We need to be able to deal with things like cause and effect, because at the end of the day, healthcare is about changing what happens to patients, giving them the treatment which is going to improve their outcomes, not just predicting what their outcomes will be in the absence of interventions. And these are huge open problems in the AI community that we need to do research on in order to have that impact in healthcare.
Great, thank you. Wei Ying, why don't you give us a quick overview of what you're up to?
Okay, I'm Wei Ying Ma. I just recently joined Toutiao. Previously, I was working in Microsoft Research Asia. So throughout my career, I have been working on search and advertising and also conversational AI. So this has been the area that I spend a lot of time working on. But over the last 2 years, I realized there's a company called Toutiao building a recommendation engine using AI to fundamentally change how people connect with information. And I really see this company is completely redefined a new AI-powered information platform, so the AI can be used not only to help the content dissemination and through personalized information feeds, but also AI can be used to fundamentally change how content and information is created, and also how we can help people to consume, interact with the information, and turn every user into a publisher. And so there's a lot of interesting new things we can do to, even in this very old area, connect people with information that AI actually can fundamentally apply and create a new things. Later on in my talk, I will introduce more about what this company is doing and how AI is used to redefine information platform.
Great, thank you. Well, so I want to start with a pretty big question, because I think it's a really important question that a lot of people struggle with, including the media. It is where we really are in AI, because I think there's often a tendency to kind of conflate the very powerful tools that are out there with this sort of idea of artificial general intelligence. And it's maybe not an easy thing to sort of separate this and give some idea, but I'd be interested to know if you could all maybe offer some thoughts on where we are in progress towards, I don't know, maybe not towards artificial and general intelligence, but we'll give people some sort of sense of where we are. Because we see things like AlphaGo Zero, which has been, or AlphaGo and AlphaGo Zero, which I'm sure everybody knows about, which are these amazing examples of something doing a task to superhuman level. And so it's easy to extrapolate that we have some superhuman intelligence, but I think it's more complicated. Anyway, Lisa, sorry, weigh in on that.
Okay, yeah, I think in terms of where we are, right? So, we're kind of at if you compare it to artificial general intelligence, I feel like we are at artificial narrow intelligence, right? We can, when we understand the tasks, when we have the data, we can train the models, and we can do quite well at that. What we're trying to push on right now is kind of what I would refer to as like artificial broad intelligence, or at least broader intelligence, right? So more ability to, at least if we can steer the machine in terms of which data it should go after and how it should organize it, and not have to do the very detailed task of parameter optimization to just kind of go after a specific task, then to me that's kind of where we are and the boundary we're trying to push against.
David, what are the big things we need to... It seems like your research is you're really looking at this issue of how to take things to the next level. So what are the big things missing, I guess?
So I think we are missing the ability to learn about the world without explicit supervision. And if you want to put a word to it, I would say creativity. Right? This is one technique that humans use to do that. We're missing the ability to do abstract reasoning about the world. And we're missing the ability to draw causal conclusions about the world. So these are three big areas.
Right. Adjust your microphone. Oh, sure.
And to give my answer to Will's original question about sort of what is the state of I'll say machine learning research today and application, I want to give you an example of what I would call the simplest possible machine learning algorithm, and then I'll argue that where we are today is not far from that. I think this might be illustrative.
Okay.
Right, the simplest possible machine learning algorithm is what's known as a nearest neighbor classifier. So a nearest neighbor classifier works as follows. We want to figure out what is, we want to put a label on an object, and so we take a data set and we look to see what is the nearest possible data point in that data set, and we compare it to that. So let's look at the 4 examples here. Let's put, what are some labels? Okay, journalist, researcher, you're a researcher, but maybe we'll just use the word industry for now, just to be simpler in this example. Okay, suppose we want to figure out, I am a new person coming in, and we want to know, is this person a researcher, a journalist, or someone working in industry? So let's compare that new person to the 4 of us. Okay, suppose this person is a woman and is a white woman. And if we were to compare the sort of facial features of this person and just do a sort of pixel by pixel comparison of the images, we might guess that they look closest to Lisa. And then we might say, okay, that person is a researcher. And it doesn't take much intelligence to build such an algorithm, right? First of all, there's no learning per se. All we're doing is we're doing literally a pixel by pixel comparison between the 2 images. Now, that type of algorithm, that nearest neighbor algorithm, it'll work well if you have a ton of data. So, for example, Lisa might be, suppose that we're a reasonable strategy, she might be looking forward, might be looking to the left, might be looking to the right. And if you just do a pixel by pixel comparison between 2 pictures of people like her, if the sort of face, even if it's a same picture of her, if her face is in different orientation, then you wouldn't get a good match. Unless you had enough images of her in different orientations, then you would get a good match. And so these nearest neighbor algorithms are dirt simple, but they start to work really well once you get a huge amount of data. Now here's the controversial point I'll make, which is that today's deep learning algorithms, if you really look deeply at what they can do and think about them, I would argue that they're not that far beyond what a nearest neighbor algorithm does for you. They do a lot of clever aspects about, in essence, parameter sharing, allowing you to learn from a little bit less data than you would need otherwise. But at the end of the day, they still need a huge amount of data, and they need a lot of supervision. They need labels associated with each of those things. Would you call that nearest neighbor algorithm intelligent?
I wouldn't. No. That's a very interesting way to put it, definitely. Wei Ying, do you want to offer some thoughts?
Yeah. The way I look at AI innovation today and all the disruption AI is creating nowadays, I think the fundamental thing is really now we are given a very powerful tool to create intelligent software. So it's a revolution in software industry. So we all know that software is eating the world today, but not many people know that software industry itself is also being disrupted by deep learning. This is a new way of creating software. It's not like we have a software engineer using their own logic, create rule-based program, and to do certain kind of thing. Now this software are essentially very big and deep models with billions, trillions of parameters can only be learned through machine learning algorithm based on big data. And so it's a fundamental new way of creating software, which is also eating the world. So that's the reason now we have this kind of big trends going on. The digitalization of everything now gives us big data. And everything connected gives us further control to all kinds of Internet of Things to bring AI to create AI city. And the third is really the computing resource is actually also increasing. So give us the big compute power to train very big and deep models based on big data. So I think this is all now come together that fundamentally redefine software. So right now, every time when I go to university, I tell the student now, particularly in the computer science, I tell them now they need to learn new tools. They cannot be just in the old generation. Software industry is completely new. And I think, so fundamentally, we are moving from digital representation of world through deep learning to create semantic representation of the world. So AI today is actually representation learning. I somewhat agree with David that it's not that far away from creating a much better representation to give you very quick nearest neighbor search. If you have enough example that you can train that transformation, nonlinear transformation from digital representation to semantic representation. And based on that representation, you can do all kinds of intelligent things, detection, recognition, classification, risk management, decision making, all kind of human level intelligence, So, but the fundamental things is the same. It's a representation learning, and but this capability is already very powerful enough for us to almost go to every traditional segment to fundamentally redefine using data, using algorithm, using speed of light for transaction to convert almost every industry into AI in power. So the opportunity is tremendous already, given the capability now we have.
Right. I think that sort of points to the kind of tension that I see is that the technology is disrupting a whole bunch of things. And even in the really simple examples of processing medical images, that can disrupt whole industries and ways people work and stuff. But at the same time, I think it's a really good point that this is, and the media is completely complicit in this. The AI is not, we're not anywhere near that, the grand sort of goal. I'd be really curious, because there's probably a lot of people here who are in AI, wanting to get into AI or wanting to work in it somehow. I'm curious, David, have you seen any stuff which you're like, there's maybe coming out of labs and you're like, this is more like real intelligence, this is more promising? Is there anything like that? Or are there particular areas where you're like, this is where you should work in order to really make some progress and maybe have the next deep learning sort of payoff, I guess, maybe? Should they just come to your lab and work there?
Yes, I'm hiring.
There you go.
As are they, I'm sure.
Oh, yeah, right. I'm sure everyone is.
No, I don't think there's something I would call out as this is intelligence right now. But I do think in the last 3 years there's been incredible progress toward this notion I was referring to as unsupervised learning. Right. And there really were some new ideas in the field, which has pushed it forward. It's not just about more data. It's not just, but actually some fundamentally new ideas, and that I found very exciting.
Can you elaborate what those are? I know it might be a bit technical, but I'm
Yeah, I'll give one example. So the basic idea behind unsupervised learning is you take something that you do observe in the world, so something that you can ground, something physical like an image, for example, and you want to find some hidden representation, some unobservables. You want to quantify that in terms of unobservables, and you might think about this as, what are some underlying factors that might have caused the thing that you viewed? That's the goal of unsupervised learning. Now, most algorithms for doing that, in some way or another, alternate between taking some existing model which links the observable to the unobservable, and predicting what the unobservable might be for each of the data points in your data set, and then improving the model in some way or another. And that one step of how do you take the observables, the things you see, and trying to predict what the unobservables might have been, in the past was the slowest step of the unsupervised learning algorithms. And the big advance in the last couple of years is speeding up that one step. And it so happens that one can speed up that step using deep learning.
Are you talking about like generative adversarial network stuff, or?
So what I'm referring to in my example was a technique called variational autoencoders.
Okay.
But generative adversarial networks is intimately related to that.
Okay.
They're both learning the same family of generative processes that I was just describing.
Okay.
And together, I'd say, are really at the vanguard of what I'm referring to as this breakthrough in deep learning,
okay,
in unsupervised learning.
And you probably are following this even better than me, but in case anybody isn't, the idea of unsupervised learning is instead of instructing a machine with lots of labels and examples, you let it go and learn from the world, which is a pretty wild kind of idea. It's pretty exciting. And Lisa, you must be looking at this somewhat. You were talking about some examples of the limits of machine learning and AI, and this is obviously a big area of interest, right?
Right, yeah, and I think maybe just kind of going back to your question as well about, what should people be studying and these sorts of things, right? So I would encourage people to think of, all of these deep learning techniques, the VAEs and the CNNs and the RNNs, all of these sorts of things, they're tools, right, for you to understand. It's not necessarily the thing that's going to last forever. When we're looking for people and what we're hoping that people will be studying in school, right, is that, it's really about being able to have the combination of applied maths and computer science skills that will enable people to think about the AI tasks that they're trying to perform, or they're trying to get the machine to perform, and then how do you formulate that in a way with some of these tools, or come up with new architectures, new ways of doing that? So people who have a great understanding of how to take a problem and formulate it as an optimization problem that can then the machine can then learn over in order to train the model is really important. Being able to think as we were saying earlier about what's the right representation that's going to try to support multiple reasoning tasks, right? So not just a model that's trained specifically for the current tasks. So I hope that people, students especially, because we've seen this, we see everyone gravitating towards just machine learning and just deep learning. And we think it's really, really important to also get that firm foundation in terms of reasoning, knowledge representation, optimization. These are all fantastic, deep skills areas that are very much applicable to machine learning, next generation of AI, but maybe people don't look a little bit deeper to understand that.
Right, yeah, it's worth remembering that deep learning was kind of or neural networks were a backwater for a long time, right? And the people who seem to be doing the smartest stuff are people who have a very broad perspective, from my view.
Rigorous approach, principled, I'm sorry.
And artificial intelligence, back when it was first sort of envisaged, was about much more than computer science, right, as well. It was about cognitive science and neuroscience all coming together, and I think that's a really strong idea. And so it sort of leads me to one question that I have, which is about whether there are sort of risks in the technology being concentrated in a few companies, because that's something that we're seeing happening. And I apologize because you guys on the either end have vested interest in this, but you can sort of speak to it generally. And it seems like if a technology is potentially as impactful as this is, whether there ought to be sort of movements to try and share the data or that sort of thing. How do you sort of feel about that, Lisa?
So actually, that's something I feel really strongly about. In fact, if you look at the partnership that we did with MIT, right? We went out and we said, look, we want to make sure that everybody, all the researchers, keep publishing, put it out there. We want to make sure that the researchers have the ability to put their code into open source, put it out there. We support, being able to do spin-offs and startups out of the lab. Very important to us. So why? Why would a company that might be trying to hoard all of these techniques, why would they kind of do that? The reason is because we believe that it's way too big for any small set of companies. We need, we need a huge ecosystem of different companies